take a look at today's lesson. Today we will be able to draw or sketch a quadratic function and identify key features. We will be able to explain the important features of a quadratic function. So let's take a look at today's do now. Let's take a look at today's do now. Complete the table. Pause the video, complete the given table. Alright, so here is my table complete. What I did was I input the given function into my calculator and found the y values for every given x value. Our thinking for today. What are the key features in a quadratic function? Quadratic functions. A quadratic function or quadratic polynomial is a polynomial of degree 2. The graph of a quadratic is always a parabola. A quadratic function has the form y equals ax squared plus bx plus c. This is known as standard form. So some of these special characteristics or the key features, as we will identify them, are: we will need to identify the y-intercept, which is always going to be 0, y. We will need to identify the roots, also known as the x-intercept, and those points are always x, 0. We will need to identify the vertex and also this dashed line that actually passes through the vertex. So I'll start with that one. This dashed line, this vertical line, is known as the axis of symmetry. It is an equation that is x equals negative b over 2a. Now what are a and b? It all depends on your quadratic. The vertex is actually the point containing the x value of the axis of symmetry. This is also known as the turning point. So if I look at the do now, I know that the vertex is this point 0, 0. How do I know that's the vertex? Because all other y values on the left and right of it start repeating. So that is how the vertex is found. The vertex is also special because it will be a minimum or maximum point. A is never equal to 0. The sign of A shows whether the function concaves up or concaves down. How do you know when a function concaves up? It's going to look like a regular U-shaped parabola, and the value of A here will always be some positive number. I know that a parabola is going to concave down because I'm going to have an upside down U, and here the value of A is always going to be some negative number. So that's how you can tell whether a parabola will concave up or concave down. So example number 1, we want to draw or sketch key features using a quadratic function. Answer the following. Part A wants us to draw the given function y equals 2x squared minus 12x plus 10. B, determine whether the function concaves up or down. C, write the equation of the axis of symmetry. And D, identify the domain and range of the function using interval notation. So what we are going to start off with is, I am actually going to start off with part B. Does the function concave up or down? That's easy to answer because I am identifying the value of A. Here I have a positive 2. Since I have a positive 2, this function will concave up. So what I'm going to see is a regular U-shaped parabola. What we are going to do for part A, our drawing piece, is we need to identify the key features. What are our key features? The intercepts, the vertex, and the axis of symmetry. So I am lucky here because this is a calculator question. All I'm going to do is input this into my calculator to find all of those key features. All right, so I am going to start off with my y-int is 0, 10. I am going to identify my root or roots. In this case, I have 2. I am going to find my vertex, my turning point. And my axis of symmetry is always the equation x equals whatever the x value is on the vertex. All right, so here is our parabola. My axes. I'm going to plot my intercepts and my vertex. And I'm going to create my U-shape and then plot the other point. Don't forget, it is a U-shape function, so you want to make it as parabolic as possible. All right, so there's my U-shape. Let me identify my key features again. So here I have the point, my y-intercept is 0, 10. I have my x-intercepts at 1, 0 and 5, 0. And I have the vertex at 3, negative 8. I am going to draw in my axis of symmetry, and that is the equation x equals 3. And I am done with my drawing piece. For part C, we want to write the equation for the axis of symmetry. We already know what the axis of symmetry is. I am going to do this algebraically using the formula I gave you. So for part C, the formula says x is equal to negative b over 2a. Now, what is the value of b? B is negative 12. And we need to know the value of a, which is 2. I am going to input these values into my formula, and I should get x equals 3. And I do. So x equals 3 is my axis of symmetry. For part D, we are finding the domain and the range of the given function using interval notation. So the domain of any polynomial is always all real numbers. So negative infinity to positive infinity. The range for this function starts at the minimum y value, which is right here at negative 8. It is included, and we are going to positive infinity. Okay, so let's take a look at question 2. Consider the parabola f of x equals 2x squared minus 5x minus 3. We want to draw the graph of f of x. We want to identify the coordinates of the x-intercept, the y-intercept, and the vertex. And we want to write down the equation of the axis of symmetry. This is a non-calculator question, so we cannot use our calculators. In order for us to do our drawing piece, which is part A, we are going to actually need to find some of the key features, which are some of the stuff that we need for part B and part C. So I'm going to start off with part B, the x-intercept. So to find the x-intercept, we know that is a point on the x-axis, which means that the y value is always 0. So what can I do? I can replace f of x, or y, with 0. And we're going to try and factor this. So I'm going to factor using AC method, which means I am going to multiply the a and the c term, giving me a new trinomial. Why do I do this? Because it's easier for me to find two numbers that multiply to negative 6 and add up to a negative 5. Those two numbers would be a negative 6x and a negative, or should I say a positive x. So what am I going to do? I'm going to bring down the original 2x squared piece, the original last term in back, and I'm going to factor this by grouping. Now don't forget this is equal to 0, so I'm just going to put equal 0 in the back. I'm going to factor my front piece by taking out that GCF, which is 2x, leaving me with a x minus 3. I'm going to take out the GCF for the back, which is just a positive 1, giving me that x minus 3. And I have my two roots, my two x-intercepts, which are x equals negative 1/2 and x equals 3. Now they do want me to write the coordinates, so I'm going to write my x-intercept as ordered pairs, negative 1/2, 0, and we have 3 comma 0. For part B double I, we are going to pretty much do the same thing, but this time looking for the y-intercept. The y-intercept is always a point on the y-axis, which means that the x value is always 0. So in this case, I'm solving for y, or f of x. I'm replacing all my x's with 0, simplifying this, and giving and finding my y-intercept to be a -3. Just like before, we want to write it as an ordered pair. So I'm going to write my y-intercept as 0, comma, -3. The last piece is we want to find the vertex. Now, before I find the vertex, I am actually going to skip over to part C, which is the axis of symmetry, because I need the x coordinate to help me find that vertex. So I am going to write down my formula, which is -b over 2a. I have my a term here, my b, and my c. I am going to replace that -b with a -5. I'll show all my work here. 2 times a, which would be times another 2, giving me my axis of symmetry to be 5 over 4. Now, why did I need this? Because in order for us to find the vertex, I need this special point. This point is going to be the x value I am going to plug into my equation to help me find the y value when I input 5/4. So I am going to go back to part B, and this time I'm going to solve for y. So I'm going to replace all of my x's with a 5 over 4. And I'm going to evaluate. Again, there's no calculator, so you have to be careful here. 5 over 4 squared, you're distributing that to each piece, the numerator and the denominator, giving you a 25 over 16. Here I'm going to multiply that -5 with 5, which is -25 over 4, and I have a -3. So let's just keep multiplying across. We have 50 over 16 minus 25 over 4 minus 3. And I'm looking for f of x, right? So at this point, I'm going to find common denominators. That way it's easier for me to work with. And I'm going to be able to get myself my y coordinate. Okay, so I made it to -98 over 16. Now you do want to simplify. I see I can divide this by 2, giving me a -49 over 8. Okay, so now what is the vertex? Because that's what we're looking for here. The vertex would be that x value of 5 over 4, and my y value is -49 over 8. The last thing, let's go back to part A. So for part A, we wanted to draw my quadratic, my parabola, and it's not going to be super nice, but everything that I have found already will be on my grid. So here we have the x-intercept of -1/2, 0, 3, 0. We'll put them there. We have our y-intercept at -3, 0, -3, maybe somewhere here. The vertex probably somewhere here. And the axis of symmetry we will draw in. So let me just connect what I have, and if I need to, I will readjust. Okay, so here are all my key features now. So we have the x-intercept. This first one was -1/2, 0. My y-intercept over here, 0, -3. My axis of symmetry or my vertex, I should say here, is 5 over 4 comma negative 449 over 8. And we have the last intercept here at 3 comma 0. Besides this, I am going to include the axis of symmetry. So I'm going to cut my parabola right through the vertex and label this x equals 5 over 4. And this would be the drawing of f of x. Again, not super accurate, but every single key feature is labeled on my x and y axes. So let's take a look at the next question here. We have on the same set of axes, sketch the graphs of the following functions. We have f of x, x squared, and g of x, x squared minus 2. They gave us restrictions. For each function, write down the range for the given domain, and we want to look at the intersection point with the line y equals x. So again, I noticed that this is a calculator question. All I need to do is input this into my calculator to plot the points of f of x and of g of x. So this is f of x. There is my parabola g of x. So we want to find the range of f of x and the range of g of x. The range would be what is the lowest value of that f of x function. In this case, that would be 0. And it goes all the way to 9. So 0 is included, goes all the way to 9. For my g of x function, minimum point is at negative 2 and goes all the way to 7. So that is the range of the given functions. We want to determine the point of intersection or points of intersection with the line y equals x. Y equals x is the line that crosses the origin. So here I see 2 points for the f of x function and 2 points for the g of x function. And that is it. Keep learning, keep growing, and I will see you in our next video.